Dámy a pánové, já vás zdravím, tady je Sara Polak, opět s dalším dílem Pioneer Talks. Opět přesedláme do angličtiny, so please let me just switch into English because we have a very esteemed guest. Someone who I instantly, it's almost weird how quickly we became friends when I went to the Moonshot Leadership Camp in America earlier in May this year with an excellent sense of humor, a fantastic headband, a fantastic business, and generally just a fantastic person overall. Andrey, welcome to the podcast.
Thank you, Sarah. Pleasure to be here.
Thank you so much. I gotta say, just like to be honest with the public, that you arrived in Prague after Berlin when?
About 24 hours ago.
24 hours ago, and you know you're crashing with me, and I kind of thought, hey, do you want to do a podcast? And I thought that was a brilliant idea, so here we are.
And naturally, I couldn't refuse an offer like that.
Exactly. Andrey, just so I introduce you to the public a little bit better, what is it exactly that you do? So like we met in America, which we can talk about afterwards as well, but I just want to introduce you as the great person that you are.
So I'm involved in some eclectic ventures. I'm originally an aerospace engineer. I work in the space resource industry for a company called the Asteroid Mining Corporation. The clue's in the name. We're trying to access resources from asteroids. And in my spare time, I have a mushroom farming company. So I have taken several tangents and trying to fuse them into one.
I love that. And honestly, like as someone who is trying to like justify her life's choices of combining like archaeology and technology, I very much like agree with that style of venture. Let's start with the first one. So the asteroid mining company. That sounds incredibly difficult and incredibly expensive. How does that work?
So it's a bit of both. I'm going to correct you for a start. It is the Asteroid Mining Corporation. That is my boss's main pet peeve when people call it the Asteroid Mining Company. But yeah, Asteroid Mining Corporation, founded about 7 years ago. It's a bit of a misnomer at the moment because we focus mostly on space robotics before integrating the whole value chain. It is incredibly expensive, as you can imagine. But at the same time, I think it's absolutely necessary for humanity to start accessing the resources outside of our biosphere. So we are focused primarily, we try to map it onto the same thing as the mining value chain. So mining in terrestrial mining tends to follow a kind of set formula. You start with prospecting, where you go and kind of find the resources, see if it's there. Exploration, where you do some core sampling and prove that it's there. And that's when a resource deposit becomes an ore. So an ore is something that is economically viable to extract. Once it's proven as economically viable, you can get investment in to start saying, okay, let's bring in the machinery, let's start digging it out. Once you start digging it out, that's the extraction. Then you process it and transport it on to the next destination, where you manufacture, et cetera, et cetera. So we are focused primarily on exploration robotics, so enabling people to actually ground truth the resources in space.
That's fascinating because I know with the prospecting, that's where archaeologists are your biggest problem, because the moment you find any kind of skeleton or artifact there, everything halts and you're not allowed to dig anymore unless you're an archaeologist. So that's just like a sign point I wanted to make. At the same time, like definitely like on Earth, there's a lot of ecological things to like take into consideration in terms of mining. There's a lot of also very state-driven aspects of this. It's very political. Of course, like you've got the neo-colonial aspect, but you've also got the fact that you have to bring in like very heavy machinery, and then the things that ore is then used in is often perhaps controversial in terms of like general ecology. So how does that work on asteroids? I presume that you have to land there, or how does that work?
There's definitely a lot of ESG involved, like ESG considerations involved in terrestrial mining. You have to integrate with local stakeholders. If you have a village above your lovely patch of unobtainium, you're going to have problems. Where asteroids, I mean, from some of the mining execs I've spoken with, they almost seemed a little bit jealous because at the end of the day, these are, as far as we know, dead chunks of rock floating in space, just left there from the formation of the solar system. There's no natives, there's no indigenous peoples to displace. There's also no biosphere to damage. So there's definitely a lot of legal matters to catch up on in terms of like ownership and appropriation. Which I can get into later, but it's honestly quite rather dry. But overall, it's probably a more ethical way to extract resources than on Earth.
What are like the main materials that you're focusing on, or that's most of interest?
So we are primarily actually resource agnostic. We're developing the enabling technologies. I think the main resources of interest are probably water ice and also rare metals. So water ice, just the same water you have in the oceans, really, just frozen all up, is spectacularly useful both for life support for astronauts, for extended missions, but also as a propellant. So for those of you who don't know, to move in space, you have to basically throw something out of the back of your rockets. And water is great for that. You just put in electricity, split it into hydrogen and oxygen, recombine it, it gets very hot, shoots out the back, and there you have rocket fuel. If you can find a way to extract that there, you have in-space gas stops, essentially. The other one, of course, is platinum group metals. So they're very, very rare. Platinum, you're talking like 200 tons of production per year, plus minus 10%. But it's a spectacularly useful industrial product used for chemical catalysts. So catalytic converters in cars, for example, that actually uses platinum to move out some of the more harmful gases before it's ejected into our lovely biosphere. On top of that, it has a lot of uses in jewelry, of course, because it looks great and very shiny. As well, it's one of the most biocompatible materials. So it's one of the few things that can be used in implants and your bodies won't reject it. And finally, a major component in hydrogen fuel cells.
Okay. But by the way, this, you think it might sound dry, but actually it really interests me because, like, when you do find and locate an asteroid, traditionally, like, getting to the asteroid in the first place was like a hugely state-involved matter. Like, of course, now people like Elon Musk are changing that, but your company needs to get there, drill it, and then kind of come back. Are you a component in the supply chain of like space travel, or like how do you exactly like fit in there when you do locate an asteroid? And how might you locate it? That might be useful to you, and do the exploration. How do you then actually get to the stage of exploring it?
Well, I think that's one of the main differences between what you're seeing now in the current like kind of new space economy, as it's called, versus the Apollo program era, because that was entirely government driven. In fact, it was a bit of a should we say a measuring contest between the two major powers, the Soviet Union and the US. Primarily a prestige project. Of course, there was science involved as well, but who can one-up the other? New space is very different in the regard that it's very much profit-driven at the end of the day. These companies are going up there because they see that there is economic opportunity. But it also means that unlike when it was government-driven through the Apollo program, where you had to do everything from train the astronauts to build the rocket ship to actually go there to get all the telemetry, there is a lot of actual companies that are targeting different points of the value chain because unlike Elon Musk, unfortunately, we don't have untold billions in capital to expend. So you have to really focus your efforts on that which can be done in the near term and also be commercialized in the near term. So we are not focused on the transportation in any way. There is much cleverer people building rocket ships and much richer people building rocket ships at the end of the day. There's no point in competing there. It's finding something that is an enabling technology that no one else is doing that can also be commercialized in the near term. That's the key. Once you have a core that does that, then you can expand into other parts of the value chain as needed. So we're on exploration. Our main product is actually what is essentially a spider robot. It has 6 legs rather than 8, but it's needed for moving around on the surface of asteroids. For those of you that don't know, asteroids are quite small relative to Earth, which means the gravitational field of them is also very weak. Which means that unlike Earth, where or even Mars or the Moon, where if you have a wheeled rover and you spin the wheels, you just go forward because gravity presses you down, there's friction, and the wheels move against that. If you try to do that on an asteroid, all you need to escape its gravity is about like 1 centimeter per second squared. That's like you poke a finger at it, you push, and you are sailing off merrily into the distance. So if you try to have a rover that does that, again, you spin the wheels and you go, wee, and that's the last you'll see of that rock. So you need something that can actually grip the surface and move around onto it, almost as though it's climbing over a climbing wall. And that is the robotics we're developing today.
That's incredible. And so how would like the ideal use case look like? Like, would you have these robots on a asteroid exploring, I dare say, ship, or like some kind of projectile where it lands on the asteroid and the robots kind of like get out of it and they try to collect samples, go back, and then you fly back to Earth, or they kind of analyze it in situ? Like, how does that work?
That's actually, you've pretty much described the 2 competing mission concepts we have at the moment for our asteroid exploration probe, which is planned around 2028. So it does essentially involve going to an asteroid, rendezvousing with it, landing on it, and then deploying these robots to go around and take samples. Now, whether they have to actually take the samples back to the spaceship itself, and come back to Earth, really depends on the amount of sampling equipment that we can put onto the ship itself. it may make more sense to bring it back just to have a higher level of certainty in what's there. Or it may make more sense just to take the samples, analyze them on site, relay the telemetry back, and fall on for the main mission. It's really a matter of gaining a high enough level of confidence to say, we know what's there. We can guarantee you this is how much is there when we process it. Give us money.
Yeah, absolutely. It's interesting because, like, maybe even like studying these things at a distance. I know a guy called Petr Škoda, who's an astroinformatic, and they study the atmosphere of exoplanets in the distance, and they try to figure out what gases they might be made from. And I do wonder whether like the huge spike in AI might help with not necessarily having to land on the asteroid, but actually like studying like it from a distance. But then again, you don't know what's under the surface, right? Yeah.
Well, that's absolutely very related. So the same telescopes that are looking for exoplanets at the moment, you often have these asteroids kind of just going across their field of vision, and they are logged. The difficulty lies in being able to classify them just from a surface reflection. Sometimes you can know where they are, you can figure out what their trajectory is, you can even get a vague idea of what's there. But just due to the fact that you're getting a small amount of light reflected, that's coming back, there's a somewhat limited amount of information. A lot of the information we're getting on their compositions and their locations is actually from missions that aren't specifically looking at asteroids. Things like, well, now the James Webb Telescope, but previously things like the Legacy Survey of Space and Time, which is imaging pretty much the entire known universe. And these are things that are enough to kind of point us in the right direction. But the jury's still out on whether it will provide a sufficient level of confidence to say this is worth spending $100 million to actually get there.
Yeah. And by the way, just like coming to you as a person, as Andrey, so what did you study and how did you wind up like in this amazing endeavor, which is incredibly cool? How'd that happen?
So, I mean, I guess the simple answer is I read a little bit too much sci-fi as a child. Like Arthur C. Clarke, Isaac Asimov. It really got me thinking about what's out there versus down here. So when I got to the end of high school, I was like, what do I want to study? Well, I don't want to be bored at the end of the day, so I'm going to challenge myself. And I thought, what's challenging? Oh, I know. I'll do aerospace engineering. So I became an aerospace engineer kind of towards the second or third year of my bachelor's. Still a little bit lost. Didn't have all these lovely internships lined up like Airbus or Boeing or anything else. But I thought, well, space resources is very cool. I think it has inherent potential. It's an inevitable step in our progression as a species. I'd like to do that. As you can imagine, there's not many companies that were doing it, especially this was back in like 2018, 2019. So I sent out a bunch of cold emails, 0 replies altogether. I think I emailed pretty much every space resource company in Europe, quite a few in the US as well, and just no luck. And the next thing I know, I wake up one Wednesday when we have no lectures and just happen to have a text from one of my friends saying, oh, I remember you were talking about asteroid mining once. There's actually an innovation space talk I was at the University of Manchester, so they were hosting one there. And it was just like, yeah, there's a guy speaking at asteroid mining. You should come along. Came along, heard his talk, offered to buy him a pint, and then just actually ended up going from there. We clicked. I liked his kind of roadmap. I think I offered something fairly insightful, and since then I've been working. It was a couple of years unpaid prior to us getting funded, where I was just contributing to the roadmap. We got funded for just over $1 million about 2 years ago.
Amazing.
And since then I've been working as the chief strategy officer for them.
That's amazing. So, by the way, what did you study at Manchester?
Aerospace engineering.
Aerospace engineering. That's figures. That's fair enough. So in terms of the strategy, like what does that look like, and how do you also, coming from the startup scene myself, like it's often very difficult to kind of like reconcile like the dreams and the hopes with then the reality of the funding and like what can be achieved. Also, given that you're relying on so many people, so how do you work with that? Like, what do you do?
Well, I guess as the historian Saya Berlin used to say, you have to match the means to the ends, and I think that's very important because the ends are potentially very lucrative, but very expensive, and also to a certain extent quite far away, both literally and metaphorically. So it's really a matter of seeing where you are at a given moment in time, figuring out what you have to work with, and how that fits into the overall vision and bringing it all together. So for us, for example, it was seeing that we don't, as a young startup, have the capital to do the entire value chain. We can't both work on the rocket ship to get us there. The extractor technologies, the market, and the prospecting, and the surveying. We have to focus on one thing. And it was finding one thing to focus on that would allow us to both develop the enabling technologies needed for the long term and also something that can be commercialized on Earth. So for me, it's actually been finding this technology and then seeing what could we use to make money with it.
Yep.
Which is, I have to say, for the space resources industry, a pretty novel concept. There's been quite a few companies, not, as far as I'm aware, other than government grants, none of them have made money, like zero revenue. So for us, it was taking this robot, which we've been developing for surface exploration on small bodies and the moon, and saying, okay, what's nearer term? How can we apply this to industry on Earth in such a way that we can get revenue from our technology and then also push that revenue back into the overall roadmap?
That's amazing. And what are the use cases on Earth where you can do this, presumably in mining as well? Or
So yeah, I don't want to go too far into it because that's slightly sensitive. But
Fair
I think
enough,
there is there's a lot of use cases for a legged robot, especially one that can actually climb over surfaces and on inverted surfaces. I'm sure you've seen Spot, like Boston Dynamics robot. There's a lot of dog robots at the end of the day. But what we have is a robot that can actually go on walls and inverted surfaces. It has modular grippers, so you can change them out depending on what surface you're going on. Whether that's like a lava cave on the moon, or the outside of a skyscraper, or a ship, for example. You can switch out the parts. So for us, what we've actually ended up settling on is just industrial inspection. Going and delivering sensors and inspecting infrastructure where humans are expensive to put. Whether that's expensive due to very high skills required or due to the insurance premiums for a high-risk job, like going up on scaffolding, going down ropes, going into mine shafts. So we're applying a robot there to try save human lives and, at the end of the day, save operators money.
I got to say, this is something interesting as a byproduct as well from our research group that we found out, because we're taking Plato's Polis that we want to recreate in VR to understand kind of like social complexity. But we actually understood like very quickly that beyond like our kind of philosophical wet dream, you have the idea that you can simulate things like cave-ins and like other of these things like on Earth that are actually useful to someone beyond someone who has a fetish for Plato, that you can actually help to fund the research kind of like and back propagate it in that way. So it's amazing that you've taken a very kind of like almost hackers approach that like, yes, this is like what you want to do in terms of extraction on the asteroids, but at the same time you found an industrial usage. And I got to say that especially in academia here in the Czech Republic, it's often difficult to bridge that gap between the robotic innovation or just innovation in general that happens on universities and the industrial use case. That they're two very kind of disparate worlds, and that scaling kind of that thing in industry sometimes can be difficult. So it's amazing that you achieved that.
Yeah, and to be fair, I'm very glad I found the niche I did. Because I was never the most talented of engineers. There was always people in my course that were much better at doing very specific things like fluid analysis, structural things. But I was fairly good with words and I was fairly good at synthesizing ideas. And for me, this was a perfect role because I could work both on the technical side and actually speak to the technical people and understand what they're saying. But then simultaneously look at the possibilities and try to make the means match the ends.
Well, honestly, it's one of the reasons, and like, I don't want to make you feel awkward because I'm like complimenting you so much. But at the same time, it's one of the reasons I invited you, because in the modern technological world, I feel constantly like on the back foot with humanities. I'm thinking, like, what am I doing in tech? Like, it should be the technical people who actually know how to code and program and do all these things. But at the same time, like, the more that technology is scaled and developed, you do need the interdisciplinary approach, and you do need people who might not be, I'll never program a program, but I can do a strategy around it. And that's nowhere near less valuable than actually doing the thing as well. Like, you need to implement it and you need to scale it. So you're doing amazing work. And I've got all the fingers crossed for you that you mine as many asteroids as possible.
Yeah, I appreciate that, Sarah.
My second question leads on to your cheeky startup on the side that we discussed just now as well when we were preparing, but also at Moonshot, which concerns mushrooms. Now, I will leave the description up to you because I would probably screw it up. But what do you do exactly and how did it come about?
Yeah, absolutely. So I ended up finding a second passion beyond my sci-fi, which was actually farming fungi. So my startup, Grow Your Own, is essentially a startup that designs the environmental control systems and the data collection systems to allow you to optimize the processes around growing fungal crops. They're not a crop that's gotten very much attention, to be honest. We've always grown plants of various sorts. We farmed a lot of livestock. There's this whole quite unexplored kingdom of the tree of life, which is fungi. And even though they've been farmed in certain points in time, whether in Paris in the catacombs in the 1700s.
Really?
Yeah.
Really?
Catacomb mushrooms.
Seriously? Okay, this is
well,
very
it's perfect.
cool.
It's nice and cold. It's quite moist. Lots of organic matter, I guess. They were also farmed in Japan traditionally.
Yep.
But in the West especially, it's quite a mycophobic culture. So for us, like mushrooms are associated with death and poison and, witches' huts with chicken legs in the woods kind of thing. So we haven't really explored them. And they haven't been explored much as a food crop, which is a real shame. So when I discovered them in university, started growing with a housemate of mine. Our first grow was shiitake. And we were both aerospace engineers, and we were quite impressed by them, to be honest. Because I'm sure most of our viewers have seen kind of windowsill gardening. You have a little cherry tomato plant, some microgreens. We had a cherry tomato plant. This was in Manchester, so one of the rainiest parts of England. Like sunlight comes out maybe 30 days a year, if you're lucky. We had one of our housemates had a cherry tomato plant on the windowsill, and 3 months later, it gave us like 2 tomatoes. It was like sad. Incredibly unimpressed by it. And that same housemate got a grow pack of shiitake. So a grow pack is essentially just a block of organic matter that contains kind of the mycelium, which is the body of the mushroom. The same way that like a cherry is the fruit of the cherry tree, the mushroom is the fruit of the mycelium.
Okay.
So he got a pack, and then about 2 weeks later, maybe even less, we had like half a kilo of shiitake, like fresh, that we could just cut off and chuck in our cooking. And then a week later, we had another half kilo of shiitake. And this is comparing to these piddly little cherry tomatoes, like, whoa, okay, this is interesting. And decided to grow it myself with my dear friend and course mate, Nina, well, now co-founder, Nina, and realized it was actually a lot more work than we initially thought.
Yep.
In fact, it was a hassle. We had to repeatedly mist it. We had to keep it at the right temperatures. Had to be in a humid environment. Had to be fanned. Being engineers, obviously, we're perfectionists, so we wanted optimal results. It led to us trying to humidify our rooms to keep it at the perfect environment, which did end up with a fungal colony actually pretty soon. It just wasn't the fungus we were trying to do. We had black mold in the ceiling within like 2 weeks.
Oh God.
Yeah.
Oh.
That took some fumigating and some rubbing alcohol to get out of there. So after that particular episode, we were like, oh look, okay, we're engineers. We should not have to be manually misting and fanning and etc. Why don't we automate this process? Let's take a box. Let's take an enclosed space. Let's make it regulate itself. And yeah, that's how my mushroom journey started.
That's amazing. So how long ago was this? Like a few years?
Yeah, this was like end of my second year of uni. Yeah, probably a little bit over 2 years ago now. It wasn't really a commercial venture at first, really. It was us just tinkering and trying to actually put our engineering degrees to good use.
Yeah.
I think it actually only became commercial when our university decided to give us money.
That's amazing, really.
Yeah, we.
Wow.
So our university has an accelerator program. An accelerator is just kind of like they take business ideas, they vet them, and if they think they have some kind of legs to stand on, they'll give you a certain amount of money and some coaching on standard business practices and what a business plan actually looks like, that kind of thing. Very basic, but it gets you off the ground.
That's amazing. Yeah.
As I heard, wow, our university is giving thousands of pounds of free money. This isn't a business, but hey, I mean, I might as well try.
Yeah,
it's free money.
Yeah.
So sitting there like, okay, how do I sell a box that grows mushroom to my universities? Well, this should be a food product at the end of the day. And at first it was literally just like, okay, well, if I make something up that's vaguely convincing, they'll give me money, right? It's as good an incentive as any of us. And as I looked into it further and further, I realized, wait, this actually really, really makes sense as a food product. Like they're underutilized, but nutritious. And yeah, I ended up with what was meant to be just kind of a making stuff up for my uni to give me money into something that's like, wow, I believe in this as something that can really affect the global food system.
That's incredible because so I was in Ethiopia at the end of last year, and there was we basically did like a little bit of a hackathon, like a accelerator, and one of the people there did a great startup in terms of growing mushrooms, but it was much more of a concept than like an actual like invented self-fanning, self-humidifying box. And one of the things that I don't understand, I'd love to tell our viewers as well, is you mentioned that the mushrooms are nutritious. Do they take a lot of energy to digest, or like how can they be best incorporated into like the food system? Basically, like what are the benefits of mushrooms for eating?
That's an absolute great question. and one I've been harping on about for the past 2 years, more or less. There's been a bit of a vertical farming craze in the past couple of years. I think it was seen as part of the future of the global food system, where you can grow food anywhere, any kind, in season, no pests, organic, and just use it through technology. One of the main issues we've had with the vertical farming system today is the fact that plants require sunlight. So if you are growing plants indoors, you have to go and replace that sunlight. And sunlight is quite energetic, especially right now. Now there's like 30-something degrees in Prague and very, very sunny. But we're talking like a kilowatt per meter squared per hour.
Really?
I could be wrong on that.
Yeah.
But it is intensely energetic, which is why solar power actually works. And the same thing, like plants require it to grow. So if you're growing indoors, you need to replace the power of sunlight, the power of a gigantic multi-gigaton ball of fusion in our sky with your lights, which you have to generate energy for. Those have to match the right wavelengths and then beam down onto your plants to grow them. Mushrooms have this spectacular advantage, which they do not photosynthesize. They actually gain their energy in a similar way that we do. They digest stuff, they respirate, they take in oxygen, breathe out carbon dioxide. Breathe being a loose term since they don't have lungs. But yeah, they have a similar mode of respiration to us, which means that if you take the replacement of sunlight out of the equation, you go from an incredibly energy-intensive industry to something which requires very basic controls in terms of like energy sense. You really only need a right temperature, a right amount of humidity, and a good amount of oxygen. So the right amount of fresh air exchange. The other amazing factor about them is they digest stuff. And by stuff, I mean organic matter. So what they grow on, it's called the substrate. That's what the mycelium grows in. That primarily, often if you see like mushrooms growing in the woods, for example, they'll be growing off like a dead log or off a tree, right? That's because they're actually using the lignocellulosic matters, like plant matter, as nutrition. And they're slowly breaking it down and converting it into more mycelium and more mushroom. And this has great implications for the food system because we can take stuff that is currently more or less unused. Things like, for example, timber industry waste, like wood chips. Things like coffee grounds. Things like waste from breweries. Anything that had a plant-based origin can essentially be dried, sterilized to a certain degree, and then fed to mushrooms. And once you feed it to mushrooms, they will colonize it, they will start digesting it, and they will give you these delicious and nutritious fruits out the other side.
That's incredible. So where are you at with this right now? I mean, you've been doing it for a few years. You got a grant, which is amazing, from your university. And if you're a Czech university watching this, please adopt this system because it's very cool. In the Anglo-Saxon world, the accelerators for startups at universities are next to none. So I'm really happy that worked out for you. So I've got two questions. What does your engineered box look like? And also, like, what are the use cases and how are you working with the startup right now?
Yeah, absolutely. So, I mean, we've actually taken a pivot or two in the 2 years we've had. Initially, it was meant to be a consumer product. So we started up with a box just to let you grow mushrooms at home, really, because that's what we want at the end of the day. This was cool, but we started developing it, developed a whole system around it. We over-engineered it, to be quite frank with you. Being two aerospace engineers, we started poking around like, oh, how can we get multimodal PID? I'm not even gonna explain that. It's not
please
worth
do. What is that?
It is a control system that involves quite complex calculus to kind of smooth out the curves of variation. Amazing. It's not interesting enough for this. But we messed around with all kinds of sensors and CO2 levels, etc. We spent so long engineering this as engineers without a product designer that we ended up with something that looks like a piece of lab kit and is pretty high tech, but not really a consumer product at the end of the day. So we ended up just taking the system, taking it out of the box, kind of just leaving a skeleton almost, and implementing this with mushroom farms. It's like commercial mushroom farmers in Manchester and in London, and letting them take their existing mushroom farming setups and turn them into smart farms, like bringing precision agriculture to the mushroom space. Amazing. Letting them vary the stuff, like just on their phone, they can actually tweak the CO2 levels and tweak the humidity, keep track of the batches that are going through their system. And we started rolling that out and then realized, oh, there's really not that many mushroom farmers. There's maybe like 400 in the UK. Of those, maybe 30, 40 major ones, which already have their own like very bespoke, very like HVAC systems and very expensive kit. So we're left with a bunch of like fairly small farms, like boutique almost. And that's not really enough to interest venture capital or anyone else. So we thought, okay, we've got this really cool system that we spent like 2 years working on. We need to commercialize this. How do we do that? And what we came down to at the end of the day was restaurants, funnily enough.
Okay.
Where you could actually take a similar concept, which is just an enclosed space which has a good environment to fruit mushrooms. Thought, let's put this in restaurants. Because mushrooms, I mean, for those of you, like, they're pretty common, right, in supermarkets. But what you have is just the portobello mushrooms. They're the bog standard little brown mushrooms that are a bit dull and not very flavorful, and everyone knows and not many people actually like. That's like eating just rice and saying you don't like plants.
Yeah.
There's a whole world out there of mushrooms, and restaurants, especially like hot cuisine, is really getting into it now. Like, they're having a bit of a moment.
Really interesting.
And they have a very short shelf life. They're not very available, and they're actually quite finicky to grow as well, which is why the supply is quite low in the West. So what we thought is, what if we take these mushrooms, and with these super short shelf lives and hard to find, and let's just put them into the restaurant themselves. So let's actually deploy a small farming unit, like a fruiting chamber, where they complete the last stage of growth into a restaurant. Send them little packs, and let the chefs, once they see it's ripe, just harvest it themselves. Like, take a farm to plate time of minutes, as fresh as you can possibly be.
That's incredible. So wow, that makes a lot of sense, and that is incredible. And you're absolutely right. I remember living in the UK in Tesco's. You've got the portobello, and then like occasionally like the ones that are already dead in the containers, essentially. What are the most favorite mushrooms, and also like how do the restaurants react to this? Like, are they, for example, worried about hygiene? Because I love that you mentioned like the anthropology of mushrooms in Europe, that we see it as connected with like death and dirtiness. So how does someone like Gordon Ramsay, who loves everything like spotless, how would someone like he react to that?
Well, I've not spoken to Gordon Ramsay yet. I'm sure that's in the process. I look forward to getting yelled at, Gordon, if you're hearing this. We've taken an interesting approach, which is we've realized that rather than building our own system, like restaurants do have cleanliness is one of the main things you have to do. When you've got food flying everywhere, you need surfaces that are easy to clean, things that are easy to sterilize. So we've taken, why don't we take equipment that is already used in restaurants and bars that's easy to clean? And just utilize that for a chamber. So we've taken things like wine coolers and bar bottle coolers, which are already like stainless steel on the inside, super easy to clean, and just added some sensors, added the control systems, and deployed them there. So for the restaurant, it's actually a very, very easy solution. It's just you get sent this block of substrate, which is essentially just a mix of like wood chips, straw, a few different bits to get like the pH right. Just get shipped to them, plop them in there, harvest the mushrooms, and then send the block to somewhere to be recycled. Whether that be for example, organic soil fertilizer, or actually one of the farms we're working with is doing beetle food.
Amazing.
There's certain special beetles which only eat remains of wood that's been digested by fungi, which meant that the European market for these were pretty much non-existent because no one was producing these. But the UK government decided to fund one of our partners to research beetle food. It's like taking the spent substrates and feeding them to beetles, which can then be used either for protein or for pets, funnily enough.
That's amazing. What are the like favorite types of mushrooms that you have?
That's a very, very difficult one to answer, to be honest. I'm actually partial to oysters. I'm a bit basic like that. I find they're very versatile. They're very fast growing. They're super tough as well. So they will like grow on pretty much anything. They will take any matter you want and just convert them into more oysters. Also really fond of maitake. It's like hen of the woods. It's quite hard to cultivate, but it's just delicious. If you haven't tried it, highly recommend it.
Definitely. I mean, like, this is really interesting because, like, in the Czech context, Czechs love collecting mushrooms in the woods. And I remember I have some friends from Sweden, and they always say, like, oh, we've got these big mushrooms growing on the forest because, like, no one wants to collect them because that's, like, seen as, like, uncouth, or, like, you don't, like, collect those mushrooms. And, like, all the Czechs are like, yep, no, that's the family tradition. You take your little wicker basket and you go for it. So I actually even think that in the Czech Republic, funnily enough, there could be a huge market for this because people are so used to eating them in, soups and sauces and whatnot. So I'm getting incredibly hungry just thinking about it.
Well, I'm actually originally Ukrainian myself, so I very much relate to that. The mushroom picking is very much an Eastern European tradition. Go into the woods, hopefully with someone that knows what they're doing so you don't poison yourself, and go and pick some mushrooms. Unfortunately, not all mushrooms can actually be grown in the same way as they are in woods. Some of them have these very complex symbiotic relationships with trees. Like truffles are the main example. One of the reasons they're super, super expensive and super, super sought after beyond their flavor is the fact they're super rare. They grow in this very complex symbiotic relationship with the trees around them that is quite poorly understood, to the point where no one can really replicate it other than by just taking the right kind of soil, the right kind of trees, and inoculating that. For that, you need hundreds of acres of land. And that's why they're still such a sought-after commodity. Now, I'd love to grow truffles in some of my boxes, but without actually replicating a tree in there, it's unlikely. So unfortunately, you cannot grow all mushrooms. Some of them are going to stay woods picked, but for the ones that are capable of just living off dead organic matter, they can be cultivated.
That's incredible. I was talking to a guy from the Czech National Museum, I say recently, probably like a year ago, and he was talking about like the communication networks that mushrooms have. If, for example, like if there's
the Wood Wide Web.
This is nuts, by the way. Could you tell us a little bit more about that? Because I love that stuff.
Yeah. So, I mean, mushrooms almost act as the nervous fibers of the woods. They seem to, as far as we can tell, the research is still at very early stages, but they seem to do everything from ferry nutrients between different trees, depending on if there is a tree that's not getting enough sunlight, which completely goes against the Darwinian kind of perspective on how nature works, where everything is, tooth and nail, dog eat dog. Where you actually have like symbiotic relations forming between things, where there's not an apparent kind of Darwinian incentive for it. You've had experiments as well. I couldn't tell you the university now, but they took, I believe it was corn, and they isolated and they exposed. All of this was connected by some soil with fungus in it. There was a mycelial network striding between the corn, but it was isolated by plastic barriers, and some of it they exposed to pests. I believe in this case was a form of beetle, which eats the leaves, and they exposed it. And usually when these plants are exposed, they release pheromones of a sort, which tell their plants to start producing the kind of chemicals which make these pests go away, which are poisonous to them. It's kind of a defense mechanism. But in this case, they were hermetically sealed from the other plants. So there was no way for the airborne pheromones to actually reach the other corn plants. And yet, the ones that were isolated and were not exposed to the pest, but were connected by these mycelial strands, started producing this chemical. So it was being used as this literal kind of like synapse connection. Yeah.
Oh my God, right. Really?
Yeah. Very fascinating, barely understood. Like, it's a completely novel area of research because it's under our feet. No one really paid attention to it until, the last 10, 20 years.
Why was this? There was like no money in it? Or like, why was the...
I mean, in the West, we thought they were gross for a start. But I think also, it's just things that you take for granted are generally things like the air you breathe, for example, and the soil you stand on. Because they're so ubiquitous and so just normal, you never seem to really think about them too much and really dig into what makes this tick. Why is it special? Because, you take it as it is.
I gotta say that mushrooms, like, I've tried to like read up ever since we met, like try to like read more about them, because as you say, like evolutionarily, like they don't make sense, and like people tend to see them as parasites, like feasting on the dead almost, but they don't see the value sometimes. So I'm really glad that you're talking about this and that we have the opportunity to chat. I've got one last question about mushrooms, and that is the ye olde psychedelics. Not because I want to make this into a drugs podcast, but because I do think it's important to be informed about what's happening in the world. And of course, like psychedelics are like one of those things that are being explored in terms of therapy, in terms of microdosing recently, for example. So is that maybe like an area you want to go into eventually as well? Like, I don't mean become a drug dealer, but maybe just like but perhaps but maybe like supply like psychedelic mushrooms to hospitals or like these types of institutions, whether that is maybe like a use case that you're thinking about, and if not, that's totally fine. I'm just freestyling in my head.
I mean,
now.
It's definitely an interesting question, because I mean, psychedelic research in medicine has been gaining a lot of traction in recent years. I think the jury's still out on whether just growing psychedelic mushrooms has many pharmaceutical uses. There's a lot of anecdotal case studies, of course. But in the pharmaceutical industry, you need like very consistent results for something to be put out as a drug in the medical sense. And I think, psychedelics don't tend to have that consistency. So when you're referring to, say, mushrooms in the industry, there is two ways to go about it. There's an isolate. So you have the active ingredient of magic mushrooms, as they're called, like psilocybin. That is the ostensibly thing that makes you trip. And that's being isolated for use in therapies against like treatment-resistant depression. But then you also, when you isolate that, the actual effects of psychedelics on our brain are still very poorly understood in terms of the mechanisms by which they act. And you still have potentially a whole host of other kind of peripheral chemicals that affect this process. So I think the jury's still very much on whether this full spectrum psilocybin, which is just the stuff that's derived from a shroom, shall we say, has medical uses. It's being explored, but it's not really an area of my specialty. I'm not a neuroscientist. And I've mostly stuck to the food space primarily because I think it is a bit of a touchy subject.
Yeah.
I will say it's a dual-use technology, to be quite honest with you. Like something that can be used to grow shiitake can also probably be used to grow things that are prohibited. But it's not, that can't be used as an excuse to say, no, this technology shouldn't be developed.
Yeah.
Because it has genuine implication for the food space.
Yeah.
To say just because it could be misused would be really limiting.
Yeah. Yeah, absolutely. And I have, like, I cannot believe, like, how amazing this podcast went from, like, I can't believe because it's you, but, like, going from all the way to asteroids, all the way to mushrooms. I think it's just, we've covered a really interesting spectrum. And I also want to give the opportunity for people, like, whether you're from abroad and watching this, or whether you're Czech and interested in mushrooms, or whatever that may be, how can people get in touch with you or support you?
Yeah, sure. So, I mean, we have a website, growyourown.me. So
Nice.
that's where we list all our products in progress. I think the best way to support us would be to start going to restaurants. So we're going to be deploying at about 100 in probably the next year.
Oh, wow. Okay.
So once we do, I mean, yeah, just go try them out in your local restaurant. We're rolling out primarily in the UK at first. But once we're planning Europe as well, because it's a pretty short logistical chain at the end of the day. Most of it's done on site. So yeah, try them out. And just generally explore. I think they are a fascinating tree of a branch of the tree of life.
Yeah.
It's been underexplored and also have so many implications for the food system. So just go and buy some for a start.
Amazing. And by the way, can you name any of the restaurants in the UK, or is that a trade secret so far?
So yeah, our lead customer is Restaurants and Barts in Farringdon. I would love to give them actually a shout out because they have a spectacular menu. They just got their Michelin star this year.
Wow.
In 2023. So yeah, Restaurants and Bars, go there. Eat
Brilliant.
their food. It's great. Say hello to Johnny, the head chef, as well.
Will do. When I start going to the UK again for my fellowship later this year, I will make sure we need to go for a pint there, and obviously mushrooms, so we'll do that. Amazing. One last thing that I want to just give a general shout out to. I mentioned that we met at the Moonshot Camp, and I just wanted to say hello to Yemi and all the friends that we met there, because it was a really interesting aspect of trying to take our ventures further, but also kind of digging a bit deep into the soul and trying to figure out what the hell we're doing, because I think that there's been a lot of at least for me, crisis of identity, whether I'm doing enough, always pushing all these new ventures forward, and it's sometimes the work of Sisyphus because it's difficult to get through. How was Moonshot for you, and what did it bring you?
That was an amazing experience. I mean, it was completely by chance, actually. I didn't realize it was happening until quite close to the deadline, and then went not sure really what to expect, and to arrive at such an amazing gathering of very different and yet very unique people. And as you said, dig into yourself to a certain degree and help you get a perspective on what you can do for the world as someone with a certain amount of agency through kind of their initiatives and their contacts has been, I mean, enlightening sounds really wanky, to be honest with you. But I certainly came away from it a little bit changed. So yeah, I'd love to give a shout out to Yemi as well, and the Moonshot platform as a whole. I know they're planning to kind of recreate and scale what we experienced as the pilot project in the near future. So any young budding entrepreneurs with a social idea, please reach out, and I'm sure you will not regret it. Yeah.
Definitely. Thank you, Andrey. And ladies and gentlemen, if you're still listening in English, then I'll just close it off in Czech as well. But just a final few words that Andrey is amazing. I'm really happy that we became friends on the Moonshot platform. And it's one of the things about technology I want to get across to you as well. It's not about just the pure innovation, which in Andrey's case is amazing, but it's also about building the relationships and being able to take that innovation forward, talking about it. And the fact that we met randomly in Prague before going to the Colors of Ostrava festival, and we're just yeah, let's film this podcast. It's a bit eccentric. It's a bit sudden, but not everything in life has to be planned, and not like every aspect of technology has to be mechanical. So I'm just really grateful for your friendship, and I'm happy that you came to us here in Prague.
Sarah, likewise, it's been an absolute pleasure.
Thank you very much. Dámy a pánové, toto byl další letní díl Pioneer Talks, tentokrát s Andrejem. Doufám, že se to líbilo, o asteroidech, o houbách a vším mezi tím. Přeju vám krásné léto, snad přežiju v Guatemala, až se vrátím, tak vám řeknu všechno o tom, jak jsme tam možná objevili pár pyramid, ale nic neslibuju, protože i AI může být omylná, ale mimochodem se tam asi teda vykoupím ve svém vlastním potu, protože tam bude asi 30 stupňů a snad tam nebude tolik hadů, takže nám držte palce, díky moc, mějte se krásně a těším se po prázdninách. Ahoj.